All right, so today we're going to try to dive into some pretty high-level math,
Okay.
but don't worry, we're going to try and make it as painless as possible.
All right.
Our deep dive today is all about how AI might be on the verge of totally, changing math as we know it.
Yeah, it's really interesting stuff. We're not just talking about AI that can just do calculations faster. We're talking about something that could totally change how we even discover math in the first place.
Exactly. And so who better to, guide us through all of this than Terence Tao, the Mozart of math?
Right.
We've got excerpts here from a recent article in The Atlantic where he shares some pretty amazing insights from his own experiments working with AI, particularly with this model called O1.
I think what's really valuable about Tao's perspective is that he's not just theorizing about AI from some kind of removed standpoint.
Yeah.
He's really getting his hands dirty, using these tools himself and really grappling with their limitations firsthand.
Yeah. And one thing that really stuck out to me was how he was testing out ChatGPT, which is what everybody's talking about these days.
Right.
Even though it's incredible with language, he found that it just couldn't quite wrap its algorithms around advanced math.
Yeah, it's a great example of just how difficult it is to take skills from one domain like language and try to translate them to a totally different domain like high-level math. ChatGPT can write you a sonnet that'll bring you to tears, but ask it to prove a new theorem, and it really struggles. I think it highlights the difference between kind of superficially mimicking intelligence versus really understanding the nuances and the complexities of something like mathematics.
Yeah, so ChatGPT is more of a poet than a mathematician, it sounds like. But what about this O1 model? It seems like
Yeah.
OpenAI designed it specifically for reasoning and to tackle harder problems than something like ChatGPT.
Exactly. And Tao did make this kind of funny comment. He compared Open One to a mediocre grad student,
Yeah.
which if you just heard that out of context, you'd be like, well, that doesn't sound very good.
Mm.
But in the world of AI, that's actually a huge compliment.
Yeah.
What he was getting at is that it showed potential, not necessarily as this standalone mathematical genius, but more as a kind of powerful research assistant.
Okay. I'm really curious about what that actually looks like in practice. I mean, how do you even collaborate with AI on a math problem?
So Tao described how he would feed O1 a problem that he already knew how to solve, almost like guiding it through the steps of the process. And what he found was that while O1 could handle the routine calculations, anytime real creativity or mathematical intuition was needed, those insightful leaps that mathematicians are known for, O1 just couldn't make them.
So it's like working with this incredibly fast, but very literal-minded assistant. They can follow your instructions to the letter, but you can't really expect them to come up with any brilliant solutions on their own.
Exactly. That's a really good way to put it. And Tao points out that this is where you see this crucial difference between how AI learns and how a human student learns. Humans, we make mistakes. We try different approaches, and through that process, we gradually develop mathematical intuition. Whereas AI models are still pretty static. They might adjust a little bit based on feedback or data, but they don't really learn or develop their skills in the same way that we do.
That's such an important distinction, and it makes you wonder if AI isn't quite ready to replace mathematicians then. What role will it actually play in the future of math? Is this all just hype, or is there something deeper going on here?
What I think is so interesting about Tao is that he doesn't really see it as this either scenario. He thinks that AI and humans actually have different strengths, which makes them much better suited for collaborating with each other than competing with each other. And one area where this becomes really clear is with something called proof assistants. Have you ever heard of those?
Vaguely, but I would love to hear more.
Okay, so imagine this. You've just spent months, maybe even years, working on this incredibly complex mathematical proof. But how do you actually know for sure that it's 100% airtight?
Yeah.
That's where proof assistants come in. They're kind of like these super-powered fact checkers for mathematicians that can rigorously analyze every single step of a proof to make sure that there are no errors in the logic.
That sounds incredibly useful, especially for these incredibly complex proofs where even a tiny error can throw the whole thing off.
Exactly. The problem is that traditionally, these proof assistants have been really hard to use. It's kind of like trying to communicate with a computer from the 1960s. You get all this clunky code and technical jargon you need to learn. But here's where Tao sees AI having this potentially transformative role. Instead of having to wrestle with all this code, he imagines a future where you could just explain your proof to an AI in plain English, and then the AI would translate it into the formal language that these proof assistants can understand.
Okay, that's a game changer. It's like having a universal translator for the entire world of mathematics. No more getting lost in translation between different areas of math, or struggling to understand complex proofs that were written in a way that's just not accessible to us.
Yeah, exactly. And this idea actually ties directly into what Tao refers to as industrial scale mathematics.
Industrial scale mathematics. That sounds intriguing. What exactly does he mean by that?
Well, think about it this way. Right now, a lot of mathematical research happens at a relatively small scale. You might have a handful of mathematicians working on a single problem for years at a time. But what if we could break down those silos and work more collaboratively on a much larger scale with these bigger, more diverse teams? That's the potential that Tao sees in industrial scale mathematics.
So it's less about replacing mathematicians altogether and more about changing the scale and the collaborative nature of the work itself.
Exactly. And it's a shift that AI could potentially make possible. Imagine these huge teams of mathematicians, all working together with their AI assistants, each one contributing their own expertise and unique insights. It's like going from this world where every mathematical breakthrough is like this handcrafted, one-of-a-kind toy to a world where we're suddenly setting up a factory production line for mathematical discoveries.
A math factory. Now that's an image.
Right.
But I see what you mean. Instead of just these isolated geniuses toiling away in solitude, it becomes a much more collaborative and potentially much more productive kind of endeavor.
Exactly. And Tao actually draws this fascinating parallel to the field of genetics. He talked about how gene sequencing used to be this incredibly painstaking process. A single PhD thesis might be dedicated to just mapping out one single organism's genome.
Right. It was so meticulous and time-consuming.
Exactly.
Yeah.
But then along came AI and high-throughput sequencing. And suddenly we weren't just mapping individual genes anymore, we were mapping entire populations. It totally revolutionized the types of questions that geneticists could ask and the scale at which they could study genetics.
Wow. Going from like painstakingly mapping one gene at a time to decoding entire populations,
Right.
that really shows how AI can like completely shift the entire paradigm of a field. And Tao seems to see a similar kind of potential in mathematics.
Absolutely. He's especially interested in what he calls broad crowdsourced problems. These are areas of math that haven't really been fully explored yet because they involve this huge number of potential connections and implications. It's kind of like instead of having these like classic hard problems in math that mathematicians might wrestle with for decades, you have these massive uncharted territories that are just ripe for exploration.
Okay, so I get how AI could help us tackle these huge complex problems, but wouldn't that kind of inevitably lead to less elegant solutions? I mean, part of what makes math so beautiful is finding these like concise, elegant proofs.
That's a really interesting question. And I think it gets at the heart of what makes mathematics so fascinating to people. It's not just about finding any solution. It's about finding the most elegant and the most insightful ones. And what Tao argues is that AI won't diminish that beauty. He actually thinks that it could even enhance it.
Really? How so?
Well, think about it. AI might be able to sift through these mountains of data and uncover a solution that we as humans might never have found on our own. But then it's up to us to look at that solution and really try to understand it, to simplify it, and maybe even find something beautiful and unexpected within it.
So it becomes this kind of partnership then, with AI doing the heavy lifting of exploration, and then humans coming in with their intuition and creativity to try to interpret and refine those discoveries.
Exactly. And this is where Tao's perspective gets even more interesting. Because he's not even just interested in AI helping us solve existing problems. He thinks that it could actually help us uncover entire new areas of mathematics, fields that we haven't even conceived of yet.
Wow, that's kind of mind-blowing when you think about it. Like, every time humans have invented a new tool throughout history, whether it's the telescope or the microscope or the computer, it's never just helped us answer our old questions. It's always revealed new questions, entirely new layers of reality that we never even knew existed. Tao seems to be suggesting that AI could be that next truly transformative tool for mathematics.
Exactly. And he gives this one example, this broad crowdsourced problem that he's been working on himself. It's in an area of math called universal algebra. Have you ever heard of that?
I can't say that I have. It sounds pretty intense.
It can be. Essentially what it involves is trying to find common patterns and structures across totally different areas of mathematics. And this particular problem that Tao has been working on, it involves thousands of equations with literally millions of potential implications. It's the kind of problem that would take generations for humans to fully explore on their own.
So it's like trying to map out an entire continent. But instead of mountains and rivers, you're dealing with equations and mathematical concepts. It sounds pretty daunting, to say the least.
It is daunting, but it's also incredibly exciting. And it's exactly the kind of challenge that AI is uniquely suited to help with, because AI can help us to sift through this vast landscape of equations and identify potential connections and patterns that we might otherwise miss.
So it's like AI is this searchlight, illuminating areas of mathematics that were previously hidden in darkness. But if AI is so good at finding these solutions, why do we even need human mathematicians anymore?
That is the million-dollar question, and it's something that Tao addresses directly. He argues that while AI might be able to churn through all this data and come up with some kind of answer, it's often up to human mathematicians to really interpret those answers, to figure out what they actually mean in a broader context. He's less interested in AI simply replicating human capabilities, and much more excited about how it might open up entirely new avenues of inquiry.
So it's not just about finding the what, it's about understanding the why and the so what of a solution. That's where human intuition and creativity become really essential.
Exactly. AI might be able to tell us that a certain equation is true, but it's up to us to figure out why that matters, how it connects to other areas of mathematics, and what new questions it raises. That's where the real magic of mathematical discovery happens, in that interplay between rigorous logic and creative insight.
This has been an incredible deep dive. It's super clear that AI's role in mathematics is still very much unfolding. But Terence Tao's insights provide this really thought-provoking roadmap for the future. It really seems like we're on the cusp of a whole new era of mathematical exploration, one where human ingenuity and artificial intelligence can work together to push the boundaries of what's possible.
It's a future full of exciting possibilities, and it's definitely one that's going to shape not just the field of mathematics, but also our understanding of the world around us.
It's like we're standing at the edge of this totally new world and all our old maps are useless.
Right. And that's what I find so exciting about the way Tao thinks about this. He's not afraid to just embrace the unknown, to ask those big what-if questions that might seem kind of crazy at first. Like, what if AI could help us unlock these secrets hidden within prime numbers that mathematicians have been puzzling over for centuries? Or what if it could help us build entirely new mathematical systems for understanding these super complex things like the human brain or how the universe evolved?
It's like AI is giving us this little peek into a whole dimension of math that we couldn't even access before,
Yeah,
and showing us these patterns and connections that have always been right there in front of us, but were just beyond what our human brains could process.
exactly. And that brings us back to the importance of human intuition, because AI might be able to nudge us in the right direction or highlight something worth taking a closer look at. But at the end of the day, it's still on us to make sense of those discoveries, to connect the dots and find the meaning in those patterns.
So it's not just about having the raw processing power. It's about having those aha moments, that spark of insight that helps us bridge the gap between data and actual understanding.
Exactly. And that's something that Tao really emphasizes, the importance of cultivating those skills, of knowing what to focus on, of knowing which questions to ask and which paths to pursue, even when you're dealing with just an overwhelming amount of information.
It's like being a detective in this world of infinite clues.
Right.
You need the analytical skills to sort through all the evidence, but you also need that gut feeling, that intuition, to tell you which leads are actually worth following.
I love that analogy because it really captures the potential of this partnership between humans and AI. It's not about one replacing the other. It's about finding ways to combine their strengths.
Well, this has been a fascinating deep dive, to say the least. It seems like the future of mathematics is anything but predictable. But Terence Tao's insights offer a really exciting glimpse into what might be possible. It's a future where collaboration and creativity, and a healthy dose of curiosity, I think, will be more important than ever.
It's a future where we might just surprise ourselves with what we can achieve when we push past the limits of what we thought we knew.
Now, one final thought for you to consider as we wrap things up here. If AI can help us uncover all these hidden connections within this vast universe of mathematics, what entirely new fields of study might emerge? And what role might human intuition play in helping us navigate those uncharted territories? Until next time, keep exploring.